This video discusses identifying proportional relationships when given data in tables. And you'll see here I have a picture of my dog Lucy. And if you think back to our discussion in class, we talked about what it means for a relationship to be proportional. And we use Lucy's picture to kind of help us with that. So she's just there as a little reminder for you. If there's a proportional relationship, we say that there is a constant rate of change between the two sets of data. And when we look for a constant rate of change, we're looking at the unit rate from one set to the next. And if the unit rate is the same, then we say there's a constant rate of change, and therefore there is a proportional relationship. So here's our first example. Callie earns money by dog sitting. Based on the table, is the relationship proportional between the amount Callie earns and the number of days? So let me grab a pen here. The first question I ask myself is, if I had to solve a unit rate problem, what would my setup be? Would I put days over money or money over days? And the question I'd be asking myself is, how much money does Callie earn per day? And since we're asking how much money she earns per day, my unit rate would look like this, dollar over days. And I'm going to abbreviate just with a D here. So based on that, I'm going to come over and I'm going to set up a unit rate for each entry in my table. So she earns $16 in one day, so 16 over 1. She earns $32 in 2 days, so 32 is the numerator and 2 is the denominator. She earns $48 in 3 days, so 48 over 3. She earns $64 in 4 days, so that would be 64 over 4. And she earns $80 in 5 days, so that would be 80 over 5. If I simplify each of these unit rates, and keep in mind when you find a unit rate, you want the denominator to be a 1. So I'm going to take each of these rates and make them unit rates by putting a 1 in the denominator. Now this first one already has a 1 there. But in the second one, if I divided both the top and the bottom by 2, I would end up with a 16 over 1. In 48 over 3, if I divide the top and the bottom both by 3, so that I get a 1 in the denominator, I would also get a 16 in the numerator. 64 over 4, I divide both the top and the bottom by 4. It gives me that 1 in the denominator, and 64 divided by 4 is 16. And finally, 80 over 5, I could divide both of these by 5 so that I achieve a 1 in the denominator, and 80 divided by 5 is 16. If I look at my unit rates, and the top number in each unit rate is the same, so here, you're going to see every single time I got a 16, I could say there is a constant rate of change. So we could say that yes, there is a proportional relationship between the number of days Callie works and the number of money she earns. Let's look at another example. This time we're comparing how long we drive for and the distance that we achieve in miles. So if I was to ask myself a unit rate question, I would be asking, how many miles do I drive each hour? So miles per hour. So miles is the numerator, hours is the denominator. And similar to our previous problem, I will set up a rate or a ratio for each of the entries in the table. So miles per hour, so 65 over 1, 120 over 2, 195 over 3, so on and so forth. 65 over 1 is already a simplified unit rate, so I don't have to do any work with it because I already have that 1 in the denominator. 120 miles in 2 hours, I want to simplify that so that I could figure out how far I go in each hour. And In order to get a 1 in the denominator, I would have to divide by 2. And so this would become 1. And in the top, if I do 120 divided by 2, I get a 60. And in a problem like this, I'm actually going to stop right now. Because if I look at my unit rates, my first one, I had 65 miles per hour. My second one, I have 60 miles per hour. And right there, I know that this is not a proportional relationship because my unit rates are not the same. So I don't even have to continue and find unit rates for the rest of the table. Keep in mind, when we find a proportional relationship, we can write an equation to identify that relationship with. The y and the x are the two terms you're comparing, so the miles and the hours, or the dollars and the hours. And the k is called our constant of proportionality. So the k is telling me what that constant rate of change is, or what that constant unit rate is. So if I come back to my first example, when we looked at Callie and how much money she earned, my constant unit rate was $16 per hour. So I could say y equals 16x. My constant would be 16 because that's her hourly fee. And this tells me that x is how many hours, or I'm sorry, how many days Callie works for, and y is how much she earns. So if she earns $16 for 2 days, she will earn $32. $16 for 4 days, she will earn $64. And that equation format will work for any problem as long as there is a proportional relationship.